Okay, everybody, I want to welcome you. My name is Dr. Laura Stachel, and I am the Executive Director of We Care Solar. And if you are online with us or you're one of our Facebook Live attendees, this is the first of our 10th anniversary series that's called 10 by 10. Today's session is called The Power of Innovation. And it's the first time that we've actually brought together all of our founders, Hal Aronson, Brent Moellenberg, and myself, to publicly discuss the whole process we went through in designing the Solar Suitcase. I'm going to give you a little bit of contextual background so that when we actually open up the discussion to Brent and Hal, you'll have a little bit of sense about the history that brought us here. So I'm a physician. I got very interested in the issue of maternal mortality. And as many of you on this phone call know, approximately 300,000 women die every year from complications of pregnancy. That's about the same as a 747 airplane filled with pregnant women crashing to the ground every day. And as a doctor myself, I felt that this was really a travesty because I knew from the United States that women do not need to die in childbirth, that childbirth can be considered a very happy and joyous event. So my public health studies brought me to northern Nigeria, where I was observing care in a state hospital to try and understand some of the factors that were impacting maternal health care to see whether there might be ways that we could lower the rates of maternal mortality. So this is a picture from the state hospital in northern Nigeria. This is what labor and delivery looked like in that hospital. This hospital did about 150 deliveries every single month. Yet, the hospital had 3 to 8 women dying from complications of pregnancy or from childbirth itself or from postpartum hemorrhage. I realized before I went to Nigeria that the conditions would not be identical to those in American hospitals, but I hadn't realized that a hospital could be without electricity. This state hospital did not have electricity for at least 12 hours a day. And so this picture of an operating theater shows that they could not use the operating theater lights or suction machine or cautery, things that surgeons rely on to have safe procedures. It also meant that it was not easy to do a blood transfusion because there was no power for a blood bank refrigerator. So transfusions could only happen if someone could bring with them a person that had the same blood type and no infections, and only after hours or sometimes days could a transfusion be enacted. The lack of electricity meant that at nighttime, this is what the maternity ward looked like. This room that you're seeing actually has a dozen mothers, newborns, and family members, but they are completely in the dark. And it was in this context that I first began writing home and describing the challenges I was seeing in the hospital. My husband, Hal Aronson, had been creating solar energy education programs. He immediately thought that solar power would be a way to address this issue. And so he designed a fairly conventional standalone solar electric system that would be addressing the areas of the hospital we thought would be most important for maternal health. And that was the operating theater, the delivery room, the laboratory for a blood bank, refrigerator, and the maternity ward. Now, I had actually wanted Hal to come with me to Nigeria to begin to explain how solar power could really transform care in the hospital. But he actually preferred that I go back, and I said, I have no idea how to explain solar electricity to my colleagues. So he said, let me create something that would be a small facsimile of what we would like to do in the hospital. In essence, this was a demonstration kit that Hal prepared that was small enough that I could literally pack it in my suitcase to demonstrate to my colleagues. Here's a picture of the operating room at night before we put in the large solar electric system. And here's how just actually a fairly small amount of electricity from LED lights enabled surgeons to be able to see what they were doing. This was a project in 2008. And here is the blood bank refrigerator that we installed in the laboratory. And over the next year, we actually saw a drop in the institutional maternal mortality of about 70%. And the hospital was admitting more patients because at nighttime, they no longer turned people away. Honestly, at that time, Hal and I thought we were done, but surrounding clinics began coming and asking if they too could have solar electricity because they were also working in near darkness. And so we began to purposely make suitcase-sized solar electric systems that I could carry back with me on each of my return trips to Africa. Now, around that time, Brent Moellenberg joined us, and you'll be hearing from him in a moment. And these are just some of the images to show the transformation that occurred as we created different prototypes and different iterations of the solar suitcase in preparation for something that we'd actually be able to manufacture. And many of you on this call, here's Brent. Brent and I went to Haiti, and Brent actually looked at some of the prototypes in the field, and that was something that informed him in terms of redesigning the solar suitcase for manufacturability. And this is what the solar suitcase that many of you are familiar with. It includes medical quality lights. It includes a phone charger. It includes a fetal Doppler to allow health workers to listen to a baby's heartbeat. It has ports to charge other medical devices. And it can come with a solar panel that could literally fit inside the suitcase cover, or it could also be paired with larger solar panels. And this design that Brent worked on then became manufactured at scale. And many of you know that we've now reached more than 5,000 health clinics using this technology. And most recently, Brent led the campaign to redesign the solar suitcase. And this is our version 3 solar suitcase. You can see that there are some differences. There is a optimized LCD screen. And this solar suitcase is now the one that's being installed. It comes with 4 medical lights. It has pockets to store things. And we'll talk a little bit more about some of the changes in that in just a moment. And just to show you that this portable unit actually becomes a cabinet that fixes to the wall for labor and delivery. So it actually becomes a permanent installation with solar panels installed on the roof, a home run cable brought to the solar suitcase. So Hal, when I told you about the conditions in the hospital in Nigeria, what were your design considerations? And tell me how you thought about trying to solve the problem that I was describing to you.
Well, as you know, as everybody knows, I'm a solar guy. And so I'm always looking for ways to apply solar to solve problems and to make the world better. And this was actually a case where solar was the best solution. And so when you described the problem of the hospital not having light at night, and it's in Nigeria, which has an amazing solar resource, I was just delighted to be able to actually offer a solar solution that was the right solution.
When I asked for something I could bring with me, what were some of the design considerations you had in preparing something that I could actually carry with me?
Well, it had to be able to fit into your luggage, and it had to have all the parts that are necessary for a functional standalone solar electric system. So it had to include a solar panel, a battery, and then load distribution and a charge controller, as well as LED lighting, and also sockets to plug things into that they wanted to charge up.
So do you remember when I was in Nigeria and I called you and I told you that people there wanted to keep the equipment and I knew it was your personal equipment? I didn't know what to do.
Yeah, actually that was wonderful because I thought if there's something that was as simple as that, a few components screwed on a board, wired together, and a solar panel and a battery could actually make a difference in people's lives, then I would have gotten to do something that helped other people with solar.
So Brent, can you tell us what it was like for you as an engineer? You had worked with Engineers Without Borders, you had been to Haiti, you'd seen a lot of very complex systems. Can you tell us what it was like going from those complex systems to then looking at a small portable solar electric suitcase and what you thought when you went to the field with me in Haiti?
Yeah, well, as you said, my experience to that point had been with larger systems, multiple kilowatt systems with inverters and AC wiring. And we had seen a number of problems through projects with Engineers Without Borders, just the complexity of those systems. So I knew that those were not necessarily perfect in that situation. Yet when I first saw the Solar Suitcase and just how small it was compared with those systems, I did have some concerns about whether that would be able to really affect any kind of change. Our trip to Haiti, Laura and I traveled to Haiti just shortly after the earthquake, and we're looking at systems that were there. There were a few systems already in Haiti, Solar Suitcases, and I think in that setting, it became very clear very quickly that the immediate need for light and the immediate need for very small electricity, like charging cell phones, could make such a huge difference. And so while a large system maybe is fantastic for as a want to have, a small basic system is very good for a need to have. And so that, to me anyway, became very clear on that trip.
So I think in prepping for this call, we kind of reflected on the fact that Hal was the master of new prototyping, and you came on board to try and put some standardization. So can you talk about that a little bit? What it was like for you to visit different places in Haiti and see that there was a lot of variation in those prototypes?
Sure. Well, you say that like that's a bad thing, but I think Hal has a need to make a bespoke system for every single person in the world, which is quite charming, I think. But when we got to Haiti and when we had very limited resources to work with, meaning I had a soldering iron that I had to power from a battery, I had very limited engineering materials. And as we went to each system, and you would see that each system was different, was wired differently, was built differently, it makes servicing those systems pretty unpredictable. And so, it became obvious on that trip to me that we needed to find a way to make those systems standardized and make them manufacturable so that we could make them really an assembly line kind of a process.
Hal, do you want to comment at all about why each of the Solar Suitcases did have a little bit of difference to them?
Well, I never realized that we were actually going to scale up and build so many systems. I thought we were going to help this group going to Haiti or help that one clinic in Nigeria. I didn't have a sense that we'd ever even see them again. So I just wanted to make them, and by the way, it wasn't just me, it was my neighbors on my street in Berkeley. It was sometimes high school classes that were building these things. I just wanted to make them as reliable as possible. And if I had a slightly different idea of what might work, or one of the neighbors had some really good wire that we could use or a connector, I said, cool, let's just use that.
Brent, can you talk a little bit about, what were you up against in trying to create a standardized system?
When we first got the project in Liberia, I think it was for around 20 systems. And at that point, we really hit the ground running, where we had to take what we learned in Haiti and from the other systems in Nigeria and quickly apply that to something we could build 20 of. And I think it's hard to appreciate how difficult it is to build 20 of something until you have 20 of them lined up in your attic and are trying to do all the wiring for it. And what that really showed was, again, that we needed to get off-the-shelf components that very easily would be assembled by a manufacturing group and make it so that it really was as easy as possible for the manufacturing. And that in turn would make it more reliable as well. And so I think some of those things were key to what we were thinking when we started in.
So I know that there are a lot of people that are designing things for the developing world, a lot of solar home systems in particular. There's a real push to try and make equipment that is as affordable as possible. And so we had to really think about that. How do we get something out that's affordable? But we also had other criteria because we were developing these for medical clinics. Can you talk about that sort of tension between cost and quality?
Right. Well, I think, in the travel that we had done by that point, it was pretty clear that these systems, when they went out, were going to have a very hard time being serviced, both in getting parts out to service them as well as the technicians that could do that work. And so I think that we always chose the high quality parts. We always chose the longevity over cost. And whether that's right or wrong, I don't know. But to me, it seems that it's kind of the only choice we could make at that point. And what that, what that meant is we had a system then that could run 24 hours a day, 7 days a week. The lights would stay on all night. And yeah, it'd be great to have 100 lights on all night. But if your main goal is to at least have one on all night, this is the kind of system you come up with. And I think, to your comment of the smaller, smaller home systems that maybe are similar, I think the metaphor to me would be like a car and a bus can both get you to the same place, but if you tried to regularly provide public transport with your car, that wouldn't last very long. And so, it takes the higher quality pieces. It's going to be a very rugged life for these systems, and so really you've got to concentrate on the connectors, concentrate on the quality of the batteries, concentrate on all of these things, which makes it just a more rugged system in the end.
So Brent, can you give some really specific examples, or can you see us right now? Because Hal joined me because we were kind of overdoing our bandwidth. So both of you, can you talk about some of the real specifics? Like, I know the switches, you did something special with light switches that isn't usually done, or the actual connectors. Can you give some very specific examples of that kind of quality choice that you made rather than going for the cheapest solution?
Sure. Yeah, I'll jump in on that, and Hal can add in also. I think that we had seen that so many of the failures in the field are not from a controller failing, they're from a wire getting rolled over by a gurney, or a wire shut in a door, or a connector failing. And so if we went to all this work and a 5-cent part is what took down the whole system, that seems kind of pointless. And so a specific example would be all of our switches. We decided to make circuit breakers, because even if we added fuses onto those systems, once that fuse blew the first time, there would be no fuse to replace it, and that there would be just a short piece of wire put in there in its place. And so we really tried to concentrate on no consumable materials being needed to keep the system running, and the quality, like I say, of circuit breakers, of connectors being able to be locked and very rugged, etc.
Thank you. So Brent, I heard, Hal, I heard Brent mention something about failure. He said if something failed in the field, and I know that failure was actually a really important teacher for us. So can you also speak to maybe some of the failures, some of the things that we saw when people were actually using things in the field, and how that shaped the design process?
Well, sure. I mean, the one that's most obvious to me is that when we first put them out there, I used MC3 connectors, which are standard for hooking up solar panels in the United States. And they're wonderful connectors. But in use, a lot of people would bring the Solar Suitcase inside and outside. And so they'd need to disconnect the solar panels from the Solar Suitcase. But those connectors were designed for being connected once. But if you pull them apart and put them back together again over and over again, it's causes the wire to fatigue, and they'll ultimately fail. And so Brent and I were searching, actually Brent was searching, I was just looking at what he found. We went to the automotive industry, and then finally to the music industry, and Brent found this amazing connector that was designed to be connected and disconnected and reconnected 5,000 times. That's called the Speak-On. That's from the music industry, where they set up speakers for shows. And that thing is performed beautifully. It's never failed.
Thank you. Brent, I think you have a kind of interesting example talking about the time when we went to Liberia, and just the idea of trying to get solar panels in our very first project. So just to give you guys a little bit of background to you who are listening, in the beginning, Hal did create different prototypes with a lot of volunteers that we sent into the field. And we got a call at the end of 2010 from the World Health Organization asking if we could send 20 solar suitcases to Liberia clinics. And I thought that would be a wonderful opportunity for the organization. However, we had never made 20 of anything. And just getting 20 solar suitcases from Berkeley to Liberia was a challenge. And then thinking about how do we bring the right panels to Liberia? Brent, you were on that trip. Hal, you were the one helping us source panels. Can you both speak to just what that experience was like?
Go ahead, Brent. Go ahead.
Well, I think before we even talk panels, we can talk batteries, because I can assure you that if you show up at the airport with 20 batteries in your suitcase, they're not too keen on that. I barely made the flight, but my batteries did not. So that was a great start for that trip. And I'll let Hal talk a bit about the solar panels as well.
And by the way, those batteries are not like little batteries. I mean, they're little to us, but they're like 10 pounds each. So that's what, 200 pounds of batteries that they wouldn't let you put in the airplane. I can sort of get that. And we thought we were going to get a ride on somebody's container to get the equipment over. So I quickly scored 20 80-watt panels, beautiful solar panels. And then we learned we weren't going to get a ride on that thing. And then we had somebody make us foldable panels that would fit in the suitcase. And shortly before the trip, he arrived and we started testing the panels, and they actually didn't work very well. So we couldn't do that. And so then we found these unisolar stick to the roof, peel and stick panels that we could roll up like a poster. And we thought maybe we could get those onto the airplane. And then we had to figure out how we're going to mount them. And we had to think about what kind of roofs we're going to find there and develop our own mounting system. And I invented a mounting system, which I then manufactured at the Berkeley Engineering Lab. And then when Brent got there, the roofs were a slightly different situation than what we had anticipated.
Yeah, when we first got to Liberia and started, we looked at one clinic, and all of the roofs had nails, which had a big dome on the head, and which would make a flat panel sticking against the roof pretty impossible. And so then we, within about a day, had to go into manufacturing in Monrovia, and we were able to find somebody who would form a piece of aluminum for us, and it was very complicated. But it certainly was not the way that Laura nor I had thought we would spend our first day in Monrovia, and it added complexity to that trip. The way that something.
Brent, you're being understated. It wasn't just manufacturing a piece of aluminum. It was making a new sheet of roofing. We literally attached roofing on top of existing roofing just so that our panels could be sticking onto the roof. So I think for anyone that's thinking about innovating, being able to be very flexible, to be innovative, like on the fly, I think is key to all of this. There's another thing that I know we've brought up in the past, which is the people that were doing the installations. What kind of tools did they have? What did we have to bring and put within the suitcase to make it truly complete, and so that people in very remote communities could actually conduct installations?
Well, I think Liberia is a great example of that. We had, when we sent supplies, we had sent a number of screws, and then because of the roofing situation, we needed more screws. We went to a hardware store in Liberia and found out that screws are not something commonly used there, that it's much more nails, and we definitely not planned on that. So especially the chance of finding a screwdriver is pretty unlikely. And that I think it just perfectly outlines how you can't rely on what will be in one country versus another at all. And that just pops up over and over again. And so that I think was part of what got us to add all of the tools, all the drill bits, all the screws, all the hardware, everything needed inside the suitcase.
And the silicone to plug up those holes in the event of rain.
And then everything had to fit inside the solar suitcase. So Brent and I kind of scratched our heads trying to create solar panel mounting systems. And then even something like a ladder, right? When you get to a village and you'd be ready to do the installation, could you find a ladder? And then people would sometimes run around the village and they do a great job, and you'd come back with something that was what looked to us like a bunch of sticks nailed together, but wouldn't quite reach the roof. And then we'd take the ladder, stick it on top of the truck. And, we would do things that would certainly not be OSHA approved in terms of figuring out how to install it. So the tools that we started including when we would do shipments to our partners in Africa also included ladders. Because I remember just times going around even, Dar es Salaam or Kampala, trying to find a good quality ladder that we could then give to our partners was a bit of a challenge. So people do amazing things with very little, but we still wanted it to be safe, and we wanted it to be easy to do the installations. So we had to really think it all the way through.
Right. I know safety was a huge a huge consideration for us, as was quality. And I know, Brent, you were really intent on ensuring that any of the equipment we sent in the factory would not fail. And I actually remember we had that first experience in Liberia where we brought in the 20 solar suitcases, and one of the charge controllers, not something that we make, ended up failing within a day of installation. And when we called the manufacturer, it turned out that typically 2% of those charge controllers do fail. So talk about what you did in the process of manufacturing to try and ensure that we wouldn't have any early failures in the field.
Well, I think any of the engineers that are on this call will understand this one greatly, that you can't ever detect all the failures before they get out in the field. But obviously, if we ran it through a longer test, like a burn-in test in manufacturing, and made the devices actually function, we could wash out some of those failures. And so we immediately started doing that. But it's, yeah, you'll never know what's going to fail till it gets out there.
So the other thing I want to bring up is that neither of you two had ever built solar suitcases before this whole project got going. And you had a lot of things you needed to learn in order to be able to do this. So could you speak to maybe some of the wonderful organizations and people that actually were very generous in sharing their knowledge to allow both of you to become experts at this?
Well, I don't think there were any experts in building solar suitcases that we could talk to, but I remember early on when we were realizing we were going to be sending batteries to Nigeria, meeting up with Robin Gudgel, who's kind of one of the great electronic engineers in the world of solar, like Outback and Midnight Solar. And he was very generous. And he said he wasn't sure what was the right battery to use in certain countries. So we were at a convention, a solar convention. He just walked me around to all his buddies that were battery guys and introduced me, and I got to talk batteries. Is it AGM or gel, or what would be a good battery to use in that context? And he was also the one that made the first suggestions about what would be a reasonably small circuit breaker box that we could use to send out the early systems. Still overly heavy for that, but what was nice about that was not only did they give free of their advice, he would draw sketches, he would get us equipment at cost, just very generous. And that's kind of the spirit of the larger kind of pioneer of solar community is they're excited when you're doing something that helps people, and they were very willing to help us. A lot of different companies would give us things at cost. Another one was Backwoods Solar, for example.
And Brent, what about in the terms of the manufacturing process? Did you?
Well, I want to just add on what Hal said just a bit too, which is I think that one of the more enjoyable parts of this job is that because of what we're doing, and because we're not really threatening anyone's income by taking over the whole industry or anything like that, we get to meet with groups which otherwise might not want to meet with us. And so just over and over again, every industry professional that we meet with, it's been fantastic, because we have been able to get indoors that we otherwise would never have gotten in, from Philips Lighting or Arrow or whoever it is. These groups, which would normally see us as a tiny business not worthy of their time or of being competition, are willing to sit down and just spend tons of time with us, which is fantastic.
Excellent. Well, we all know that version 2 and then version 2.1 and 2.2 were really very well received, yet we felt compelled to do version 3. Why?
That's just job security, Laura. We needed to do that. After you go to a number of installations and you see these systems and you see the midwives who are using these systems, they've got enough to worry about without having to learn everything about solar as well. And so while the controllers and the off-the-shelf parts that we were using served us fantastically, the teaching the midwives and teaching the users, it's a large process, and teaching them about, okay, you use this much power when the light's yellow and this much power when it's red, and what all these different things mean, and they've got more important things to deal with. So one of the big things that we really wanted to do is make the use of it intuitive, make it more like any kind of electronic device they may already be used to, like cell phones. By that point, were becoming more common in these areas. And so we always kind of had this dream of, wouldn't it be great if? And so we were very fortunate to receive backing to help us let us do that. And so we were able to take that time and again work with some just fantastic groups, Swim in San Francisco, and I mean just a whole number of different groups who let us look at what the user needed to know, how we present that information to them, and then how we make the device which would do that.
So one of the things I want to make sure to emphasize here is that we did not do this in a sterile laboratory. We actually did this in communication with the end users. And that really has been true from the beginning. When we first brought those early prototype solar suitcases to Nigeria, I went back to Nigeria 14 times. Every time I went back, I would check with someone that had used something. I saw what was working. I watched people turning on and off light switches. And if I saw that they accidentally turned off the power when they were turning off the light, I would come back and report that to the two of you. So I think there were a number of changes in version 3 that really were directly related to the feedback we had, such as when we actually spent time in the clinics at night, we saw that those bright procedure lights that were good enough to do surgery were actually too bright for people who needed to sleep in wards, right? So what did you do about that, Brent?
Well, we had known for a while that, that we really needed a way to dim the lights. And so initially we had sent out lights, which one small light and one large light. And then that gets very confusing when you're doing installations as to what should go where and when you need what. So we knew that a dimmable light was a really big addition. So that was definitely a feature that we knew needed to be on there. And even to the point where we wanted to be able to adjust that light to really dial it in over time to get it exactly the brightness that we wanted for low and high, or low, medium, high, or whatever. And so, this list had been running in our heads as we saw the various clinics and went out, and really saw. Again, to your point, I think that it's hard to know how people are going to use something until it gets out to the field. And even like the first time that we heard that the headlamps were very useful, because when someone went out to the latrine, it allowed them to avoid snakes on the path. I mean, that's not a problem I really have. Though if you saw my current house, you may disagree. But so those kind of things, we don't know what is going to be needed until it gets out and the users give us that feedback.
Great. I'm going to mention a couple of more things, but in the meantime, I want everyone listening to know that you can actually put a question in. If you're with us on the webinar, you can write in the chat function. If you are on Facebook Live, you can also type in a question on chat. We have people on standby who will be entering these questions. So in less than 10 minutes, there'll be an opportunity for you to have your question answered. But I was going to mention another few things that we'd seen in the field. One was that sometimes it seemed like it was very hard to keep track of things like the headlamps or the little batteries or the battery charger. We did try and create a very complete solar electric system that had not only power generation, but the end appliances. And so one of the design modifications for version 3 was actually to create little storage units, right? Where you actually now have pockets where these things can be held. Again, an example of us being in the field and seeing how these things were really truly used, and then thinking about, well, how could we make things easier for people? Are there any other things about that? For example, the actual installation process that one of you could comment on? You want to talk about
the installation process.
How did we modify that in version 3?
That was the real advantage of actually being in the country, going to the rural area, actually installing systems on the health centers, which are mud brick, often with a little bit of a thin coat of plaster over the walls, and what they call iron roofs, which are these corrugated metal roofs where the structural support is about every 3 or 4 feet, but it varies, and you can appreciate why, because resources are scarce and expensive, and each piece of wood out there is hand sawn. After you see somebody hand saw lumber, you realize why you don't have a whole lot of wood in the roof framing. So, and then we also know that people didn't have the tools and cable on their truck to just run cable, cut off the end, put on the connectors. So we needed to pre-cut the cable, make them the right length, think about how they're going to route them to the Solar Suitcase, from the panel to the Solar Suitcase. Think about what they're going to encounter. Like Brent and I were in Southwest Uganda one day, and Brent climbs up there to run some cable from the roof down into the health center. And he goes, hey, you know, there's all these bats up here in the roof. And he asked the local health director, is that okay? And the health director, very scared, says, did the bat touch you? And we learned shortly afterwards that those bats carry Marburg, which is kind of like Ebola, right? So we said, well, let's think about a different way to route our cables than through the attics. So once we got that, we started to get a sense of how long they needed to be. Once we saw what it was like to try to anchor something into a mud brick wall, we had to think about what would be a good anchoring system, yet keep it simple and make it so that people could understand that these parts are for the wall, those parts are for the roof, and just imagine what the experience is like of someone who's not a trained installer getting these parts and trying to put them in. So we kind of put all that together to figure out what would work and get the lengths right. And we came up with something that worked pretty well, I think, but it was through watching. Or another example would be, we had this big fat Nutra connector, and when somebody tried to route it through a wall, trying to watch somebody drill a hole that would take care of that connector going through the wall was just ridiculous. So we knew we had to figure out another way to do it. Yeah.
Brent, I think you even took that a step further in version 3, really thinking about the installers. Can you mention some of the design changes that you
Sure.
made in terms of the installation process?
Yeah, well, again, you know, it took a number of iterations for us to realize how people would actually install them versus how we wanted them to be installed, and what was easy. And so we really tried to take everything we'd learned and apply that to version 3, so that, for instance, one person could hang the suitcase instead of taking two while one holds and the other one drills. Put all the connections on the outside of the box so you didn't have to do a whole lot of wire routing, that kind of thing. And you know, had we not been out in the field so many times by that point, I think we wouldn't have known. You know, Hal's point about someone sawing a piece of wood by hand, I think another piece of that is when you're installing on a clinic and you realize that all your screws are twisting off as they go into the wood because there's, like, you know, ironwood or something that was used to build the framing of the clinic. I mean, that's something you just don't see here. And so you know, you just would not expect anything like that.
So you brought up something as you were talking about what we expect people to do versus what the technology should do. And I know that there was a disconnect between what we might have thought was intuitive and what people who are from different cultures, different languages, maybe they can't read all of our materials, what they're going to think is intuitive. And I know with version 3 that you made an effort to do more color coding, that you made it easier to put in lights, that we only have a very specific type of connector for each socket, so that we've made it very hard for someone to accidentally, like, plug in the solar to where a light should go, for example. I mean, there's so many things that I think we just take for granted right now because we've been doing it for 10 years, but people listening to this may not also take for granted. They may not realize that this was part of it.
I would just add also, we made it so that people could not plug their household appliances into the Solar Suitcase, because, I mean, that's one of the things that most solar people who do put in systems have learned, is this thing called electrification intoxication, which is once you provide a power system into an area, everybody wants to use it, and they have no idea what the various loads will do to drag down the system. And if you drag down the system, then the power is not available when they need it for light at night, and the batteries may never get fully charged, and then the system has a short and inglorious life. So we made it so it's very hard for people to defeat the system and use it for things other than what it was intended for.
Yeah, I think that's also really important to bring up, that before we started the Solar Suitcase, we really analyzed what were typical points of failure of standard residential solar electric systems. And so, for example, we purposely did not include an inverter. We have a complete 12-volt DC system to try and minimize the chance that people were going to start plugging AC things into the suitcase. And actually, that was part of the rationale for Brent, me inviting you to come with me to Haiti, was realizing people were plugging other things in, and it was overcoming the system.
It looks like we're getting
yes,
questions.
Yes, we will. We're going to get to those in just a minute. I just wanted to ask you both, what's next for the Solar Suitcase? I know that one of the people who just asked a question actually took the Solar Suitcase to a humanitarian application. Can you talk about the Solar Suitcase that we've used in humanitarian settings and maybe what we'll be hoping to do with version 3? Brent?
Sure. Yeah, well, we have, like you say, we have in a number of instances used the Solar Suitcase, probably more like people think of it being used always, because it's in a suitcase form. People assume it's used as a mobile system, which is generally not the case. Usually it gets out to a clinic and is permanently installed. But that doesn't mean that it can't be used that way, and it has after various typhoons and earthquakes and such. And so as we did the design for version 3, that was always on top of our minds. And so, you know, some of the decisions that we made, both in connectors and switches, in capabilities, make it more readily usable as a mobile unit. And you know, even the fact that our you know, we can connect to a much larger range of solar panels, that everything is a bit more watertight. And so I think definitely being used as a humanitarian response is something that we're very interested in pursuing, and I think that we're well positioned to do that with the base that we now have.
Great. I'm going to respond to a couple of questions that are in the chat. One person was asking about the suitcases, who are they purchased by? And something I think we didn't emphasize enough is that we don't actually work in tiny projects where we just go to one clinic at a time. We actually work with dozens and often hundreds of clinics at a time. So we work in partnership with groups that are NGOs, UN agencies, and indeed governments. We have an initiative that's called Light Every Birth with 4 different countries: Liberia, Sierra Leone, Uganda, and Zimbabwe, where we have partnered with the government to ensure that every public health center has reliable light for safe deliveries. And we depend on philanthropists, institutional donors, sometimes UN agencies to purchase solar suitcases, but we do not actually require the clinics themselves to pay, because these are most often going to public health clinics, many of whom may be rather destitute. They may not have money for things like medications, and they really cannot afford to purchase a solar electric system, which is part of the reason that they're working in near darkness. In fact, many of these health centers rely on patients to bring kerosene or to bring money for batteries for their flashlight or to bring candles. And so we are now eliminating the need for patients to have to try and provide their own light. And one of the things that we see is that more patients come to clinics when they are poor and they no longer have to pay for those other things. Okay, we have another few questions. One of them is asking about the ecosystem of medical devices and how more and more devices are becoming very energy efficient and are working on 12-volt DC. And have we had any thoughts about trying to use the Solar Suitcase as a power platform for additional devices? Brent?
Yeah, well, I mean, absolutely we have. We kind of always have tried to do more of that. You know, in the early days in, say, Nepal, I know that we were running some ultrasound machines there, and seeing the evolution of just specifically ultrasound machines, even from that time till now, you know, there are actually apps you can get for a phone where you add a little bit of a hardware to a smartphone and it can act as an ultrasound. The nice thing is that a lot of these devices have, just by the nature of technology, become more easily powered by the suitcase. And so even though we have pursued connections with different medical groups to try and come up with devices that would work well, a lot of that has just happened on its own, and what I think will continue to happen as devices just get more power efficient and everything becomes more and more portable. And I think that, you know, that is true also of communication and internet around the world becoming much more possible. And so I really think that the relatively small amount of power that something like this system can provide really is becoming more and more useful in a clinic as the years go on.
Yeah, the other thing is that so many devices now have their own batteries. So what's really nice about that is we can put a large solar panel on the clinic and people can charge up anything that has an internal battery during the daytime. And since panels are relatively inexpensive now and we can oversize them because we use lithium batteries. People can be charging up anything that's more like laptop based or tablet based to do that, as well as headlamps. Another one that we see a lot of need for that people ask for, like in Puerto Rico, Haiti, et cetera, were nebulizers for people who are having respiratory problems. And we're still looking, I think, for a good 12-volt nebulizer, but what people tend to do is put in one of those little car inverters. They can plug that into the Solar Suitcase and then plug the nebulizer into that.
Yeah, and things that I've seen in the field are blood pressure cuffs that use rechargeable batteries, and they can use the same rechargeable batteries that we put in for the fetal Doppler. That's included. We've now, in light of COVID, started putting in infrared thermometers in every Solar Suitcase so that health workers can have a no-touch approach to checking someone's temperature before they enter a clinic in order to try and minimize the cross-contamination of somebody who might be infected with someone who isn't. Another thing I think we didn't necessarily emphasize greatly was how important education is to what we do, that we actually have a lot of training programs to ensure that people locally can do their own installations. We have a whole systems approach to that. So we are actually training the Ministry of Health technicians in how to service the Solar Suitcase, how to repair the Solar Suitcase. We have a training program, and more than 800 people worldwide have now learned to install Solar Suitcases. And there's been some questions about students. And I think, Hal, you're perfectly suited to answer this. You know, what is the role of We Care Solar and our program, that's the education program called We Share Solar? What is the role in trying to help that next generation of innovators learn about solar electricity?
Well, I mean, I think that's our North Star, is that students would learn about solar electricity as part of their education, because solar is going to be playing a large part in their lives. And some of them will actually get jobs installing, maintaining, even designing solar electric systems. And that's one of the things that even when we work with health ministers and the rural energy agencies in places like Kenya, there's a real hunger for knowledge about designing systems that are well balanced so that the batteries actually have a good long life and actually power the loads that they want to power. So the We Share program, we're actually teaching teachers, we're actually giving them Solar Suitcase kits that they can use with their students. And so they'll both get a Solar Suitcase installed at the school, but the students will also be learning from the Solar Suitcase kits or the suitcases that are installed. And we're going to now start training young people in refugee camps in both Uganda and in Kenya.
Great. So that'll be an opportunity for people to have their hands on a very safe 12-volt solar electric system. And, you know, I showed that picture for those of you that could see the slides of sort of a large solar electric system that you had designed for the hospital, but really the principles are all there right in the Solar Suitcase. So
absolutely.
It's a very good opportunity for young people to learn this. Well, I wanted to ask two more questions. Brent, can you talk a little bit about the remote monitoring capacity of the Solar Suitcase and why you designed the Solar Suitcase to have remote monitoring?
Sure. Well, I think that as we've kind of covered earlier in a lot of the talks, once these systems are out at a remote clinic, it can actually be really hard to get information about problems on the system. Some of that is just the physical of the distance and the communication problems. Some of that may be cultural, that people who have a system may not want to tell us if it's broken because they think that we'll be mad or whatever, which is definitely not the case. We've instituted a number of situations where we'll call the clinics to find out if the systems are still running. And so while we were designing the version 3, we thought, well, why can't it call us? And so really that was something that we added in from the start, the ability that it could then use cell phone towers to send out data and a heartbeat basically to tell us how it is. And so that is something which is easy to include on the latest suitcase.
Now, I would just take what Brent said and I would just twist it 180 degrees and say, it's not only there to tell us about problems, it's actually there to tell us that the systems are still up and running, right? And it also tells us how people use it, because by getting the data, we can tell what kind of loads they're plugging in, are they using it all night long? And so there's a wealth of data that could then go into tuning up our designs in the future as well. because most of the systems actually hold up pretty well. Brent and I tend to disagree on how long the lithium batteries will last. I tend to think they're going to last a little longer. Brent wants to be a little more cautious, but we'll find out really accurately in about 5 to 7 years how well they last based on that kind of data collection.
Well, Brent and Hal, you've done an amazing job over the last decade. I know in trying to summarize things in a short call, it almost makes it sound like this was an easy process. And I think that we may have not really emphasized how incredibly challenging it was to be designing things for people in another country. Some of the logistic challenges, you mentioned how hard it was to get the batteries on the plane back when we were doing that program in Liberia. And I should mention that it was Delta Airlines, and I spoke to their marketing department and said, please get them on, or I will let everyone know that Delta did not let these get on, but they did. So I plugged for them. But we had logistical challenges when we moved from sealed lead acid batteries, which required replacement every 2 years, to lithium batteries, which we think might require replacement every 5 or 7 years. We knew that was a better technology for the suitcase, but they were considered hazardous goods. And that almost put our logistical shipments to a standstill when we tried to figure out how do we get these solar suitcases onto airplanes when they're being considered hazardous goods. And so there were a lot of challenges. I just mentioned a tiny one. I want to know for each of you, what keeps you going? Because I know there's times where you feel like throwing in the towel. So Hal, how about you? What keeps you going and doing this? You've now been doing it for more than 10 years.
Well, I mean, I think of myself as a solar evangelist. I used to have hopes that we would actually be able to slow down climate change and so on. I'm a little bit pessimistic about that, but to know that something that we make can actually really help other people keeps me going. And to know that we're helping people who are really competent but stressed be able to do their jobs, like a midwife or a doctor, or a surgical technician in a hospital in Nigeria, that they can actually do their job and not worry about the lights going out, et cetera, and not be so stressed, really gets me going.
Thank you. Brent?
Well, I guess I echo a lot of what Hal says too. And, you know, over the years, really, I mean, our mission is maternal health. And I think that, you know, if you look at it, you assume it's for the mother, for the baby, which is true. But really, when you are out there and you see these people who have devoted their life to healthcare, who've gone through all the training and then are put out in a clinic in the middle of nowhere that the lights go out every night, that's just unacceptable. And so if you're able, with really a pretty basic system, to provide light for those people and to make their life a little bit easier, that's a pretty small gift for you know, for my life, given what they're doing with theirs. So
Cool. Well, I really want to thank both of you for everything you've done. There's a couple more questions right now that I think we can address. For all of you who would like to, the hour is up. And so I think for those of you who would like to drop off, you can. Otherwise, you can also share your cameras now and unmute yourselves. You can put your videos on. We'd love to actually see all of you. There are actually many people on this call that were very important parts of the We Care Solar journey. From people who was our COO, like Robin Wolliner. There was Suraj Shah, who literally carried solar suitcases on his back over avalanches in Nepal to try and reach small clinics. Johnny Weiss is on the call, who has climbed on rooftops with Hal in Tanzania and brought solar suitcases to many countries that we haven't even been to yet.
Bob Staten is on the call,
Right.
who inspired me in energy when he was a professor or a teacher at Cabrillo College about 40 years ago. That's so amazing.
So for all of you that are part of the We Care Solar family, thank you. For anyone else that would like to continue asking questions, please, you can go ahead and unmute yourself. I believe I'm going to try and see if I can unmute everybody or someone else who's helping me do that. And
Laura, it's already been done.
Okay, great. So anybody who would like to ask a question, please go ahead.
Don't all raise your hands at once.
Sure. How much does the suitcase cost?
Completely with everything in it.
Okay, so what we tend to talk about rather than the actual cost of a suitcase is how much does it cost to sponsor a health clinic? Because a solar suitcase is part of a very big equation that includes shipping a solar suitcase to a destination, picking the clinic, making sure people are well educated, making sure people locally are trained to do installations, and then ensuring that the solar suitcase is serviced and cared for many years. And for that first 5-year process, it's about $3,500 to support a clinic. Now, each of those clinics do approximately 200 or more deliveries a year. That means that there will be 400 mothers and babies in 1 year that receive the benefit of the suitcase, and over 5 years, that translates to about 2,000 people. So for a little more than $1 per person, you've actually provided the opportunity for safer deliveries. The other thing to know is that many of the solar suitcases are actually used not just for deliveries, but for a range of frontline medical services. When I was in Zimbabwe in February, they were being used for all sorts of primary care, for taking care of accidents at night, for vaccinations. We have them in operating theaters. So you really are supporting an entire community when you support a solar suitcase. And if you would like to learn more about that, please write to us, info@wecaresolar.org. I know that Samantha Parsons, our COO, has already put that address. Maybe you could put that up again, Samantha. And we'd be happy to talk to you specifically about things you may be interested in.
So that's a long way of saying $3,500.
Hi, Laura.
Hi.
It's Susan from Southern California.
Hi, Susan.
Any thought about including pulse oximeters for the babies?
Yeah, so we actually have some pulse oximeters that I ordered from China. We've been testing them out. Anytime we make a change to the solar suitcase, we really want to do it in parallel with our Ministry of Health partners and make sure that we are really responding to things that they need. And we are looking at a suite of medical devices that, that could be included in the solar suitcase. And if we find that there's a very strong interest for pulse oximeters, I think that could be arranged. But as of yet, that has not been one of the primary requests from our partners.
Thank you.
Hi, greetings, Dr. Laura, Hal, and Brent.
Johnny?
Yeah, Johnny Weiss here from Solar Energy International. You guys are rock stars. It's been a pleasure to work with you. Laura, what are your goals for the next 10 years? Tell us about what you want to do.
I'm really glad you asked that, Johnny. I think that, you know, when Hal and I started, we were sort of working at one clinic at a time, and we never really knew what it would take to scale. And we've had some wonderful people join the team and really allow us to create a framework for scaling. We know that the Sustainable Development Goals are calling for the eradication of energy poverty by 2030. That means that by 2030, everyone in the world should have access to clean, modern electricity. We should have energy efficient devices. And I think We Care Solar can really be a leader for maternal health care being part of that 2030 goal. We would like to see every public health center, in fact, every health center in the world, have reliable electricity. But as a nonprofit, we are really putting our attention to those that tend to get a lot less attention, which are the public health centers that may not have a lot of resources, that may not have an immediate market-based solution. We're also trying to think about how would we finance such an audacious goal. And if you haven't yet seen the 10 by 10 series that we have offered on October 8th, Impact Alpha's David Bank is going to be hosting a session specifically about financing. We think because we have a very cost-effective solution, we actually could reach the majority of health facilities in the world that don't have any electricity with solar suitcases for, I think it's like $500 million. Like, we really could solve this problem by 2030. So if you have interest, if you have thoughts about how to help solve that problem, it's going to require lots of people being involved, and not just with solar suitcases, with other solar and renewable energy solutions for healthcare. So we'll need a lot of people to sort of be joining the coalition to really end energy poverty in health facilities, but I do think it can be done. Any more questions?
Hi, I had a couple questions. Where do you do your manufacturing? And can you talk a little bit about how you picked the manufacturing site? And then also from the big picture perspective, can you talk more about how you got those partnerships with those 4 countries for Light Every Birth?
Absolutely. Brent.
Sure, yeah, I can talk a bit on the manufacturing. We do about 1,000 to 1,200 systems a year right now, which is, it's a lot when you see them all stacked up, but it's not that much by world standards of manufacturing. And so when we started to make the current version of Suitcase, the version 3, we sent out a pretty extensive bid to a number of manufacturers, both overseas and locally. In addition, we've got some really good partnerships with some people who have really spent a lot of their career in manufacturing. And so we were advised that at this level, probably it makes more sense to manufacture in the US. So from the bids, we ended up selecting a manufacturer in Colorado, which is coincidentally where I live, totally unrelated to that we chose this place. But they've been a fantastic partner, Premier Manufacturing. Along with that, we've also worked with Aero Electronics, who has done amazing things for our supply chain in getting all the different materials into us and at good prices. And so it was a long process, but again, as I said earlier, I think that we really are lucky to be able to work with different companies who, even though they know they're not going to make a lot of profit from us, are more than willing to work with us.
And then as far as choosing partnerships, I saw someone was asking, why do we choose the Light Every Birth countries? We actually have done landscape analysis of dozens of countries, and we are initially targeting the countries with the highest rates of maternal mortality and the lowest rate of rural electrification. So those are the areas where we really see that bringing in solar electricity is going to have the greatest impact. That's how we chose our first countries. We also are working in other countries. If you go to our website, you can see a whole map. Some of the countries we call our accelerator countries include Ethiopia and Nigeria. We've also done a lot of work in Tanzania. As far as choosing partners, we have changed the way we've done that over time. We now actually put out requests for proposals, and we let agencies in their own countries know about our programs and look for groups that are doing work in maternal child health care, but may not yet have addressed the energy access issue and are looking to partner with us. And as an obstetrician, it's really important for me that our programs are piggybacking onto organizational programs where there are many inputs being put into maternal health care. So maybe we work with a group that is working on midwifery education, or maybe they're bringing in certain types of medication to treat complications of pregnancy. But I know that that program will be strengthened by having reliable lighting through the night, so the midwife wants to actually administer a medication so you can see the bottle, measure it, start an intravenous line, and give the medicine. So we really see that our programs complement other MCH programs, and it's really only going to be by layering on these different types of inputs that we'll see dramatic reductions in maternal and newborn deaths. I see a couple of hands raised. Robert Kukuru in Uganda, why don't you tell us your question? You'll have to unmute yourself.
Thank you very much, Laura and Hal, Brent, and the team. Mine is not a question, but to bring appreciation from Uganda for the support you give us. You know how much you mean, how you have made things happen in the Ugandan communities. So thank you very much. Keep it up. This project is very viable. And we thank so much the donors and any other partner who supports this kind of work. You do a lot to Ugandan communities, especially health centers and schools. And we thank you so much. Keep it up. A big hug from Uganda. Thank you.
Thanks, Robert.
Thanks, Robert.
And I'll also just mention that Robert and his friends in that part of Uganda, Kabale, were very much part of the reason that we started expanding our education program. He was involved in a team that was helping to do installations of solar suitcases in clinics. And the team immediately said, What about our schools? And so it's really wonderful to have kind of interactions with people in their own communities, see what needs are, and then to decide as a team, what are the things that we're able to respond to. Typically, we have a hard time saying no, so we respond to way too much. But in this case, I think it really did catapult our education program. So thank you, Robert. Deborah Frankel, I see that you have your hand raised. Would you like to ask a question?
Yes, thank you. And this has been a wonderful presentation and well organized. I was wondering about something that you might not be able to do right now, but you might consider down the line, which might contribute to a small way to your financing, to your revenue stream. And that's what I wonder whether you would have considered or would consider licensing the manufacture of the suitcase to be sold commercially in developed countries, and with an add-on where a lot of the money would go to support your programs. In a developed country, you wouldn't need so much of the education component, and I can see a couple of markets for this. One would be field hospitals. Another would be both rural and urban areas that have temporary grid failures. And the third would be preppers. Using that in a broad sense, just people who want some backup for the systems they normally depend on. I would certainly be interested in buying one, even though I am not a midwife and I'm not in the health field. But if something like that were available and I weren't taking something that's needed by somebody who needs it a lot more than I do, I would be happy to pay a premium for it.
Well, thank you for that comment, Deborah. And it's something we have thought about from time to time is there are some nonprofits or social enterprises like Tom Shoes, where if you buy a pair of shoes, you're actually supporting shoes in another country. So that model has been tried, and
Right.
It is something we've considered. And to be quite frank, I think that this newest model of the version of the Solar Suitcase version 3 would probably be the most amenable to that type of process. But you bring up even a greater issue, which I find very interesting, which is that very often when things are being created for the developing world or for low-income countries, we can find that they actually can have great benefit back in the more industrialized countries themselves. And we've seen that, sometimes things like that small portable ultrasound that Brent was talking about. Well, that has great utility in Africa, but it has great utility in the United States for doctors as well. And I think that we have been seeing, particularly with climate change, particularly with crises closer to home, that we all know there's times when renewable energy and distributed energy can be incredibly useful. And to date, one of the places that we've focused on the most for that is actually through our student education program. So Hal, could you just speak a moment to some of the places where the student-built solar suitcases have had utility in the United States?
Well, a number of places. One was the Pine Ridge Reservation in South Dakota after there was flooding. There were a lot of people without power. We share the student-built solar suitcases out there. There's one on the Pomo Reservation up in Hopland, California, because they're getting ready for power outages related to the fires in California. We use them for students who live like on the Navajo Reservation, who don't have electricity for studying. And so our mobile systems help with that. So there's a number, and I know there's going to be a lot of search and rescue is another one, field research stations. So there's a number of places where having a standalone, fully contained solar electric system can be enormously useful, just like you're saying.
So Deborah, thanks. We will take your thoughts into consideration. I'll mention that even though we've reached 5,200 health centers, I think probably close to 1,000 schools, we've served more than 6.4 million mothers and newborns. Our team is very small, including our Africa team. There's only 17 people. And so we're not at this moment sort of equipped to create a commercial part of the program, but it is something we do talk about. It does resurface at our board meetings from time to time. And I'll make sure to bring that back to the board at our next meeting.
Well, I'm suggesting that you might, rather than running the whole thing yourself, license it. And then somebody else, if you didn't like the way the licensee was running it, you could revoke the license and go with somebody else.
Makes sense.
And it's wonderful to hear about the reservations. That's a really great use.
Well, thanks everybody. You've been incredibly patient. It's about an hour and 15 minutes after we started. If you have additional questions or thoughts or comments, please write to us. It's easy to reach us. info@wecaresolar.org is always works, but each of our names, Laura, Brent, Hal, if you just attach @wecaresolar.org, you could ask questions directly. We really thank all of you for helping us kick off our 10-year anniversary series. It's been really wonderful to have all of you. And if I haven't mentioned some of you wonderful supporters by name, know that we are so appreciative. Suraj, if you can turn on your voice, I'd like you to talk. Suraj is here, who is the Nepalese solar installer, who, if any of you have seen our slideshows on humanitarian, he literally carried solar suitcases on his back for hours after the earthquake in Nepal to more than 100 health facilities. And I would say, you know, it's people like Suraj that have taught us so much and given us hope. And I asked Hal and Brent what keeps them going. For me, it's people like Suraj that show me that if we can get them the technology, they will just put their life on the line to make sure it gets to those who need it most.
Thank you so much, Laura. Thank you so much. And it's very nice to see you after a long time.
Yeah, excellent. Well, thank you all. We're going to end the session now. Thank you all very, very much. And please join us next week when we'll be having a session called The Power of Women. We're going to be bringing together our women solar ambassadors who started with us in 2012, along with newer friends in the solar installation world. We have a woman solar installer from Liberia and one from Kenya. And their discussion will really be about what it was like for them to first have an attraction to solar energy. How did they get trained? What are the barriers they face? And how can we really achieve gender equity in the field of renewable energy? That will be at the same time next week, Thursday. And you can learn more on our website. It's called 10 by 10, and we have a special page describing all of our events. Thank you all.
Hey, thank you all for coming out.
Thank you, Hal.
So good to see you.
Hal and Laura, thank you very much.
Friends.